Hello and welcome. We're about to go on a journey, but this isn't just about knowing some AI buzzwords. We're aiming for true AI fluency. And no, that doesn't mean you need to be a coder. It means understanding the language of this new world. We're laying out the roadmap you'll need to navigate it all, and our journey starts right now.
Just let that sink in for a second. This quote from Nick Bostrom, he's talking about the last invention. He means that once an AI can invent things on its own, well, the game completely changes. The stakes are just that high. And that's exactly why having a clear roadmap is so incredibly important. So when's all this going to happen? Well, here's the wild part. The experts, they have no clue. I mean, you've got brilliant minds like Ray Kurzweil saying we're just a few years away, and then you have pioneers like Rodney Brooks who think it could be almost 2 centuries from now. That huge gap between the pros tells you everything. You can't just trust the hype. You need your own map. All right, so every great journey starts with a first step. For us, that means learning the machine's language. Again, we're not talking about Python or code. We're talking about the fundamental ideas that make this whole revolution tick. First up is the big one, machine learning. You know, for decades, computers only did exactly what we told them to do, line by line. Machine learning flips that whole idea on its head. This is where we give machines a whole bunch of data and they learn for themselves. They're essentially writing their own software. This isn't just a small update, it's the engine behind almost everything we call AI today. So inside machine learning, there are 2 main paths you can take. First, you have supervised learning. This is like being a student with a really, really patient teacher. You show the AI thousands of pictures and say, this is a cat, this is a dog, and eventually it learns. Then there's unsupervised learning. This is way more like being an explorer. You just give the AI a giant, messy pile of data and say, go figure it out, find something interesting. It's tougher, for sure, but the potential discoveries are huge. And what's the building block for all of this? Well, you're looking at it. The inspiration is beautifully simple. On the left, you see a neuron from a brain, and on the right, that's its digital twin, called a perceptron. It takes in some signals, decides how important they are, and then chooses whether or not to fire off a signal of its own. This one little idea, inspired by our own brains, is the tiny Lego brick that builds the entire world of modern AI. So what happens when you take these little artificial neurons and stack them up? Not just by the thousands, but by the millions. You get a neural network. And when that network has lots and lots of layers, that's deep learning. The deep part isn't some big mystery. It literally just means the network has a deep stack of layers. By passing information through all those layers, the AI can learn patterns that are way too complex for any human to program by hand. Okay, we've got the basic language down. Now it's time for our first real expedition. We're moving from just talking about AI to understanding the actual practical toolkit that people use to build it. You know what's really cool is that pretty much every single machine learning project follows the same 4-step recipe. It's a clear workflow. First, you've got to gather and clean up your data. That's step 1. Then, step 2, you use all that data to train your model. Step 3 is the big test. You evaluate it on new stuff it's never seen before to see if it actually learned. And finally, step 4, you tune and tweak it over and over to make it just a little bit smarter. Let's make that real for a second. How would this work? Well, imagine trying to teach an AI to read sloppy handwriting. You'd start by feeding it thousands of pictures of handwritten numbers, each one labeled. That's your data gathering. Then the network trains, trying to figure out the patterns of an 8. After that, you test it on a new batch of numbers. Did it get them right? Finally, you'd go back and tune the whole system to get it as accurate as possible. It's a very clear, methodical process. All right, knowing the workflow is one thing, but achieving real fluency, that's about understanding how to navigate the wilderness. This is where the clean 4-step map doesn't always match the messy real-world territory. We're moving from mechanics to pure strategy. And here is a perfect classic example of a real-world problem. Andrew Ng, a leader in AI, gives this great example. Say you train a self-driving AI on millions of hours of ultra-realistic video game footage. It could get perfect at spotting video game cars. But then you put that same AI on a real road, and it sees a classic car like this Corvette, and it might have absolutely no idea what it's looking at. That's called data mismatch, and it's a huge strategic problem. And it's not just data mismatch. There are all these other strategic hurdles. There's something called overfitting. That's where the AI basically just memorizes the answers to the test instead of actually learning the subject. Of course, there's data quality, because that old saying is truer than ever, garbage in, garbage out. And then there's this thing called hyperparameter tuning, which is basically the art of finding the perfect settings for your model. It's often described as being more of an art than a science.
Now, for the final stage of our roadmap, we're going to the very edge of the map. We're heading into uncharted territory, the frontier of intelligence itself. This is where the goal isn't just to solve known problems, but to figure out what problems are even left to solve.
I mean, we've seen AI do things that seem impossible. The most famous example, of course, is AlphaGo. It mastered the game of Go, a game with more possible moves than there are atoms in the universe, and it beat the best human player in the world. It was an absolutely stunning show of power, but it was power inside a very specific, narrow world with very clear rules.
Okay, now contrast that incredible power with this. These simple-looking puzzles are called Bongard problems. The goal is easy. Just figure out the one rule that connects the 6 boxes on the left, but not the 6 on the right. A human, even a child, can often solve these in seconds. But for the biggest, most powerful AIs we have today, they are practically impossible. And this tells us everything about AI's biggest weakness. It doesn't get abstract concepts. It doesn't get sameness.
And that gets us to the very heart of the biggest challenge, getting to artificial general intelligence, or AGI. This isn't just about more data or faster computers. It's about cracking these core mysteries. We need AI that can do abstraction and analogy, seeing how two different things are actually alike. It needs common sense, that huge ocean of unwritten rules about how the world works. And finally, it needs to understand why things happen, not just that they happen. These are the great unconquered mountains on our map.
I just love this metaphor from AI pioneer Yann LeCun. He says we've been climbing this huge hill of deep learning, and we've made incredible progress. But as we get near the top, we're not seeing the final destination. Instead, we're just getting a better view of the whole mountain range of other, even bigger hills we still have to climb. AI fluency isn't a single place you arrive at, it's a continuous journey.
So, we've sketched out the map. We went from the basic language to the practical toolkit, through the strategic wilderness, and all the way to the uncharted frontiers of intelligence itself. That map, it's in your hands now. Which leaves only one question, but it's the most important one. Where will you explore next? Thanks for joining The Explainer.